going to talk about cognitive pharmacology of depression and do that by talking about one experiment that compares the action of a 5-HT2C receptor antagonist and an SSRI that has the opposite effect of putting up serotonin in the synapse. And how can those two things be true? By way of introduction, I'm going to show you my most cited paper. And the good news about that is that it's got CANTAB in it. And the slightly galling news is that I'm only a collaborator. So here it is. And dissociable deficits in decision-making, blah, 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 in interesting groups compared amphetamine users, patients with orbitofrontal damage and tryptophan depletion. And when I realized how cited this had been, I thought, what was I doing in that paper? I'm just down there somewhere, you know. Can you see it? There. Then it took me a while to realise that we did the tryptophan depletion in Manchester, and we did it with Cambridge Gamble in that study, and in another study, which is not so highly cited, but a great paper nonetheless, we also did dimensional set shifting and looked at the effect of tryptophan depletion and compared it with in patients who were abusers. So this is just to summarise the results, and I'm not going to go through them in detail because I'm talking about depression, but that's Cambridge Gamble, and the task is to find where the key is and bet on whether it's under a blue or red square and judge how much money to bet on it. So there, it's a bit ambiguous, you wouldn't put your life savings on it, and so the task goes on. Here are the results from the tryptophan depletion part of the study, and it still amazes me that when the odds are 9 to 1 on, and, you know, of course in the normal condition, the control condition, everybody reliably bets on the most probable outcome, obviously. But these healthy people who've been depleted of tryptophan show the systematic tendency to take risk. And I'm not going to go into why that might be. I still don't fully understand it. There are many possible explanations, but one possibility is that they are less afraid of losing. But it doesn't all hang together like that. And the great interest is that it mimics the effects of organic brain disease, damage to the orbitofrontal cortex, and the effect of chronic amphetamine use, which may reflect damage to serotonin terminals. And the other is the intradimensional, extradimensional set shifting. And here you see the tryptophan depleted group here and the controls there. And it's a discrimination task to begin with, and then it gets more and more complicated, as I'm sure everybody knows. And again, the remarkable thing is that it's the discrimination reversal that's the problem. It's not so much the extradimensional shifting. And this parallels the great experiments of Hannah Clark and Angela Roberts in animals showing that local 5-HT depletion in orbitofrontal cortex reproduces that effect. So the tryptophan depletion is kind of localized to that part of the brain. And again, the mechanism of that, I'm really puzzled by what the problem is with reversing. You're going to tell me afterwards at dinner, maybe? I hope it would be good. But somehow they can't let go of responding to the previously rewarded cue when it becomes irrelevant. And maybe that's relevant to something like not being able to stop ruminating or something in depression. So the problem with this is that, I'm talking about depression. Do we think people with depression who are supposed to have low serotonin function have an orbitofrontal cortex reversal learning issue? And it doesn't seem right. And furthermore, we actually know from tryptophan depletion studies that it's involved, 5-HT is involved in mood. So this is a classic paper by Delgado et al., which has been widely replicated. And so here you see individual people who've just got better from depression with relatively low Hamilton rating scores. They have the tryptophan depletion, and you see that they all relapse. The symptoms of depression come back again. So depleting 5-HT restores the depression, and it's very puzzling. The equally unpleasant non-depleting drink doesn't have that action. And so many studies have been done with tryptophan depletion. Many of them understanding the cognitive effects of tryptophan depletion have been done, especially in Cambridge, but in other parts of the world as well. I'm not going to attempt to remember names. Roshan Cools, Ollie Robinson, who goes out of the window. But lots of people. And I know most of them. I just can't, under the stress, recall everybody's name. So apologies to them. So and many of the experiments are very hard and complicated, especially for a psychiatrist, involving tricky gambling paradigms and that sort of things, and probabilities and so on. So I resolved to spend 3 months. I was in Perda for 3 months with a postgraduate student, Paul Faulkner, And we went through 36 experimental acute tryptophan depletion studies that have been done in healthy volunteers to try and address the question of what the role of serotonin might be in rewards, punishment, and behavioural inhibition. So we didn't look at all the tryptophan depletion studies. And well, first of all, tryptophan depletion doesn't cause disinhibition of responding, so maybe that's a problem for theories that say 5-HT is about dampening down responses. But remarkably, in 7 studies, acute tryptophan depletion lessened the ability of punishments, which is usually losing points or notional money, to restrain behaviour without affecting reward. It does seem to be a transmitter that's somehow negatively valenced. And so the problem with that is, how do you, if 5-HT is some sort of punishment system, how the hell does an SSRI, which puts up 5-HT, or to make punishment worse, how does that work in depression? And this was a problem long before there were any human data. So, and it was in animal data. So my preamble is, I'm going to show you my second most cited paper. And this is good old Deakin and Graff, 1991, almost a quarter of a century ago. And so we were forced into this, trying to understand, make sense of an entirely animal literature, saying that 5-HT manipulations had opposite effects on different kinds of anxiety, and SSRIs reverse depression. So what is going on? So our resolution was to, the evidence seemed to be asked to be strong, that some aspects of 5-HT are clearly to do with punishment. And so we should, but nothing makes sense if you think of it as a unitary system. You have to think about the different functions of the different 5-HT subsystems. And the two main ones are the dorsal raphe and the median raphe projections. And that generally it's a negatively valenced neurotransmitter engaged by aversive events that keeps us out of trouble by anticipatory anxiety, facilitating fear learning through 5-HT2C receptors, mediating avoidance behavior, keeping you out of trouble, but suppressing the reward approach incentive system, and also, reasons I won't go into, restraining the acute escape panic PAG defense mechanism. So we propose, and I still think, that overactivity in this system is involved in depression and giving rise to symptoms of anxiety, retardation, anhedonia, and helplessness. And then the other side of the coin is that, again, from animal evidence, suggesting that animals that are repeatedly exposed to stress become adapted to it. And that evidence showing that 5-HT release is involved in that. So the proposal was that the median raphe, innervating largely cortical areas, is activated by chronic aversion and mediates adaptation of this response over time. And without going into details, we think it maybe has something to do with rumination, being able to stop negative rounds of thought, which maybe goes back to the orbitofrontal thing at the beginning. Another idea, and I'm not sure I'm going to have time to talk about it, is that there may be opponent processes going on, and I think I'll probably not talk about that. So the experiment I want to tell you about tests this hypothesis, and it's gratifying that drugs with 5-HT2C receptor antagonist properties do seem to be antidepressant. So agomelatine is one, it's also a melatonin agonist, and so we compare that with an SSRI. Now how would an SSRI put that right? And it could be some sort of opponent process, but my idea is that it downregulates 5-HT2C receptors, and we know that SSRIs do that. And so, well, let's get on to the experiment which compares those two drugs. And so this is a study funded by and organized by Servier. And really, I think the truth is that they wanted to show that their drug, agomelatine, is not contaminated with the sexual side effects of the SSRI, escitalopram, and also the idea that chronic SSRIs induce a state of anhedonia and loss of emotional responsiveness is not shared by their drug. So with French computational neuroscientists like Florent Meynel and others, these patients underwent a long study, 56 weeks in duration and 8 weeks, and were tested early on, in the middle and late with some cognitive tasks. And here is a simple discrimination paradigm, rather like the Pasiglione one, where you have pairs of stimuli which are positive and pairs which are negative, and there's a neutral one that sometimes is punished, and this one is not always systematically rewarded. So 20% uncertainty. And this shows the results. Within 3 days, the 5-HT2 antagonists are improving the acquisition of that task. And if anything, escitalopram is doing the opposite, as you might expect. The SSRI putting up 5-HT2C and the SUT2 blocker bringing it down, and reversing the 5-HT negative influence on reward. And it's still there after 2 weeks. After 8 weeks, everything's equilibrated out. I think they've learned how to do the task quickly, but it's still there in the steady state part of the experiment, except now the SSRI has caught up, and the accuracy is as high as it is with the 2 doses of the 5-HT antagonist. My goodness, I'm running out of time. So somehow, an SSRI is doing the same thing as a 2C antagonist. And I think that's down-regulating the receptor. It could be some other opponent processor, which I'm clearly not going to be able to talk about. The other paradigm is very interesting, looking at the symptom, I suppose, of fatigue and the effort, how patients with depression say just can't summon up the motivation to do anything. Everything's too much of an effort. So in this paradigm, they have to squeeze a stick, and you measure the force that the squeezing is exerting, and they're motivated to do it by an incentive. I think we were more generous than that. It was 10, 20, or 50p in the 30 seconds, and there were levels of difficulty, so you could trade off the incentive against how much force indicated by a thermometer they had to apply. And you can see the bottom line here, that initially in the intermediate phase and late phase there's not much difference. Only the SSRI is sustaining that effort, and the agomelatine, the 5-HT2C antagonist, is not. So here's a sort of depression-related effect, a cognitive effect of these two drugs, which are not shared. Only the SSRI does that. It doesn't seem to involve a 2C step. And they are computationalists, so it's possible to, and it's designed to, be analysed with computational methods. Basically, the idea is that there's a hidden variable which accumulates over the period when you're putting up the force, so it's kind of, it's more and more reversive to maintain the pressure, and there comes a point when you have to take a break, and that parameter is influenced by the incentive and the effort, and so you can compute which variable, the rate of accumulation, how much it dissipates, the amplitude modulation by the incentives is being affected by the drug. And the drug isn't affecting the effect of the incentives, it's affecting how much the aversiveness, as it were, of the requirement to keep up the pressure is accumulating. And this fits in with other effects of 5-HT, which improves the ability to wait for rewards, for example. It may be an example of the same thing. But to me, it seems like a kind of resilience that you can tolerate increasing demands and sustain the effort in the face of mounting degree of aversion. So since I'm out of time, let me conclude and say that CANTAB continues to make a massive contribution to cognitive pharmacology. 5-HT is involved in behavioural adaptation to adversity. Some cognitive effects of antidepressants may involve downregulation of 5-HT2C receptors, and resilience and tolerance to adversity, i.e. effort, or e.g. effort, may be independent of the dorsal raphe 5-HT2 system and involve the median raphe resilience adaptation to stress system. Thank you very much indeed.